Are you tired of uneven heating, short lifetime, and other negatives associated with vacuum tubes like magnetrons? My name is Gavin Smith, and I'm going to take you out of the dark ages and share with you another solution called solid-state RF energy. We recently released an exciting line of RF energy products. Today we will focus on the Lab Box, which is just the first member of our RFE series of system solutions. It's based on the same concept as Matryoshka dolls. 4 solutions, each one more or less embedded in the other, to address different levels of RF expertise. The Lab Box is truly designed for non-RF power engineers to support evaluation and initial prototyping of solid-state RF energy. Inside the RFEL Lab Box, you have 2 modules. These, as we call them RFEM modules, can be purchased separately to support further prototyping to create full-scale proof of concepts using RF energy. While the Lab Box is fully integrated, the modules require you to provide a heatsink, a fan, power supply, and an I2C or SPI to USB bridge. You have access to a software API to drive the module with multiple commands. You can then decide to engage with a third-party design house to customize the module and bring it to production per your needs. We are building an ecosystem of third parties around the RFE series. Alternatively, we have a third level of engagement, the palette. It is a 3-stage RF lineup reference design that you can simply copy and paste. Lastly, for further customization, and as long as you have a full RF lab and expertise, you can engage with RF the traditional way, purchasing transistors, samples, and evaluation boards to do your own design. Each level correlates with the previous to remove complexity, adding hardware and software abstraction. Our first RF Energy Lab Box is called the RFEL 24-500. This Lab Box offers 250 watts per module. It is rated for 2400 to 2500 megahertz and runs on standard outlet voltage. Here's a look at what's inside the box. We have 2 2.4 to 2.5 gigahertz 250 watt modules, a USB I2C interface, heatsink for the modules, power supply unit, and fans. Essentially, it is a plug-and-play RF generator with reflected power measurement, driven by an intuitive PC-based control software with auto-tuning features. It is a fully integrated development platform for the RFEM 24-250 250 watt RF energy module. It is designed for evaluation and initial prototyping. No RF expertise, no RF equipment required. As for the features, it offers dual module frequency control, power and phase control for each module separately, transistor temperature and module current consumption dynamically displayed, the output power and reverse power graphically displayed, frequency and phase sweeps. It has best mode function, enabling maximized energy transfer to the load, and logging and diagnostic features. Our RF energy solutions are targeted for various traditional and emerging end applications. The specific applications range from drying of textiles, wood, sand, ceramic coating, and
ink on paper, veneer on wood, drying baked goods, moisture leveling before cooking, gluing wood, books, drying fiberglass,
preheating thermoset, plastic before molding, sterilization, pasteurization of food, welding 2 sheets of PVC, emerging applications, renewable energy such as refining natural gas, biofuels, biomaterials such as algae, chemical industry, animal and agricultural feeds, processing minerals, drying mold for metal casting, medical, drying gelatin, drying water-based adhesives, drying synthetic fibers, drying sand cores, laminating the flexible and polycarbonate boards, welding PVC interior trims of cars, welding mechanical cases, inserting metal inside pieces in the respective.
wow, now that's a lot of different applications. Now I'm going to hand it over to Dave Lester, who will show the Lab Box in action.
Hi, I'm Dave Lester, Technical Marketing for the RF Energy team. Today I'm going to show you our new RF Energy Lab Box. I'll cover its features, installation, and operation. Here we have our Lab Box setup with the Lab Box on the right, blue box, and with the computer on top, as well as the loads on the left side, large black objects, as well as the interconnect cables between the two. We'll now show you how to connect this complete system, lab in a box, and operate it. Connecting the unit to the loads. The loads should be 250 watt minimum and preferably 500 watt dissipation. Once the connectors are snug, now go to the unit, and we just make sure that the power is off. Check the lights. Once we're sure the power is off, we can now connect two cables. In this case, we have two different styles of cable. One of them is Heliax, the black one, and one of them is RG393 Teflon cable. Reason for choosing one over the other, the Heliax is much lower loss, but quite stiff. The Teflon cable is flexible, but has somewhat higher loss. Here we can see the effects of the loss with a unit that's been in operation for a couple of minutes, and the Teflon cable is running about 20 degrees warmer than the Heliax cable. Continuing our hookup, we're going to hook the USB cable to the upper COM port. Once all the cables are hooked up, we can now apply the power. We can check the power condition by looking at the LEDs. Once everything's hooked up, power is on, we can now launch the application. The application will populate with the appropriate number of input dialog boxes based on the number of modules that it detects. Here it's detected 2 modules. To turn the unit on, we use this standby operating and a timer combination. If we need to turn off, we can simply push the stop button. Anyway, to turn on, we hit operate, which actually starts the timer and will be operating. We can see here the status indicators of temperature, indicating room temperature because the units have not been running yet. We also see forward and reflected power, they're empty. So now we can adjust the power. Just slide the slider, and you can see in this case 125 watts on each of the channels. We can see that the temperature is slowly rising. The current that's being that each unit is drawing. See if we can adjust the power, and it changes the actual load current. We have the option of adjusting the phase as necessary for optimal operation. We'll note on the right, there's graphs that keep a continuous recording of the whole session. So both forward and reflected power. Frequency can also be changed at will anytime. We have extended features. This opens up a new panel that allows some algorithms for optimizing the operation of the system. In this case, we've done a random search, and it gives you a number of, in this case, 100 different parameters. And we can also choose the 10 best for delivered power. These will be highlighted in yellow. If we go back to the main panel, you can actually see the frequency and phase being adjusted between those various 10 best settings. If necessary, you can reduce the number of different settings that are desired. In this case, we're going to set it to 5. We can also restrict the range on phase and frequency. In this case, you can see it jumping between the 5 different settings that were chosen by the system. If you want to go back to the main panel, we can just push manual, and then the control gets reverted back to the main panel's control. Here showing the communications logging function. It defaults to not enabled. Enable it manually. The reason that it's enabled manually is it does have a lot of overhead and slows down the operation of the system. So here we're just going to stop it. You get a snapshot of all the communications that was going back and forth between the modules and the host. In this case, the GUI. So it gives both plain text as well as the hex representation of the I2C traffic. We have the options to restrict to command only, or with or without the plain text. So we can really simplify any debugging of software written for the modules. It does not affect any of the operation other than slowing things down, so hence it's disabled typically. Here we're just showing the countdown timer getting close to its final number. We have a diagnostic panel, really for factory help. Very simple to use. Once the button is pushed, it pops up the window. You can then copy the contents to a clipboard and include it in a mail or other documentation. You can see it's actually the unit is shut down because the timer is expired. Here we just demonstrate so you can see it actually happen in front of you. So we're set for a 10-second timer. Operate the unit. You'll see as it counts down, everything is normal until such time as we reach, in this case, the 10 seconds, and everything grays out and shuts down. Also, specific other things that will cause the unit to shut down without warning are loss of communications. So if your cable gets disconnected, it will actually shut everything down and show a panel like this. So this shows in the middle of a session, check all the cabling. And if you replug the cable, it will repopulate the panels and start up in the off position. So it will not initiate, it will not start the application with the unit running. Here's a fault condition, different style. It says really what would happen if you lost the cable, the main RF cable, rather than the control cable, or had a very bad antenna or load on the system. Notice on channel 1 or module 1, the forward and reflected power are at the same level. Very, very bad match. And that one just indicates that there is a serious problem with the RF subsystem. Channel 2 is working normally.
Hope you enjoyed this exciting video and stay tuned for more. If you have any questions, feel free to reach out to your local distributor or us directly. Thank you for watching.